discussing two models. One is the paper towel model and another one is the burning calorie model. So, to start with, let us go into this paper towel model. These days many of us use this paper towel mostly in the kitchen or the dining table rather than not much in the toilet. So, the problem involves is what is that length of that paper and including the radius, the thickness of the paper. So, let us dig into that. So, suppose you have a roll of paper as paper towel. So, we are formulating the problem first. Let the radius of the cardboard core be 0.5 inch. So, if you look into this paper towel, it will look something like this and then a little bit of paper holding out, and this is rolled in some cardboard tube. So, which is termed here as cardboard core. And suppose the thickness of the paper be 0.002 inch. So, we define the variables R n is the radius of the paper wrapped n times, and L n with the length of the paper used for wrapping till n times. So, basically you have to get a relation between the radius of the paper and the length. So, as you roll the paper, this radius starts increasing and so is the length of the paper. So, we want to find a relation between the radius and the length of the paper. So, if your R n gives the radius wrapped n times, that will depend on R n minus 1 plus the thickness T. This is the thickness of the paper. So, you will have your R 1 which is R 0 plus T, R 2 which is R 1 plus T, which is R 0 plus T plus T, which is R 0 plus 2 T. Similarly, R 3 it is R 2 plus T, which is R 0 plus 2 T plus T. So, R 0 plus 3 T. So, if you notice the pattern, you can see that R 1 equal to R 0 plus 1 into T, R 2 is R 0 plus 2 into T, R 3 is 0 plus 3 into T, and similarly R n will be R 0 plus n into T. So, this gives your R n in terms of the initial R 0, the number of times it has been wrapped and the thickness of the paper. Let us look into the length. Now, if you look into the length, so if I open it once. So, it basically it is going to take this length. So, what you will get is Ln, which is the previous length, plus this whole length, which is nothing but the circumference, and gives you this length, which is 2 pi into r n minus 1. So, this is the current length, this is the previous length, and if you add one revolution, which is the circumference of this circle, you get 2 pi into r n minus 1. So, that means you the length of the paper. So, similar manner I find L1, which is L0 plus 2 pi r 0, and initially there is no length. So, your L0 is equal to 0. So, basically this is 2 pi r 0. Your L1, L2 is equal to L1 plus 2 pi r 1. So, initially you only have the core, that is the cardboard core. So, there is no paper there, and hence this your L0 is equal to 0, but initially there will be a radius of the core, which is going to be your R0. So, your L0 is equal to 0, and you get L1 equal to 2 pi R0. Similarly, L2 is L1 plus 2 pi R1. This can be written as L1 plus, which is 2 pi R0. So, this is 2 pi R0 plus 2 pi R1. R1 from here is R0 plus t. So, you get 4 pi R0 plus 2 pi into t, that is your L2. Let me go to the next page. So, what you got is Rn equal to R0 plus Nt, and you have Ln equal to Ln minus 1 plus 2 pi into Rn minus 1. You have shown that L1 is equal to 2 pi R0 because your L0 is 0. L2 is equal to 4 pi R0 plus 2 pi t. Similarly, L3 will be L2 plus 2 pi R2. L2 is 4 pi R0 plus 2 pi t plus 2 pi, and R2 is R0 plus 2t. So, I get 6 pi R0 plus 4, 6 pi t. Now, let us see the pattern. So, this L2 that can be written as 4 pi R0 plus 2 pi t. Now, this can be written as 3 into 2 pi R0 plus 3 into 3 minus 1 into pi t. Similarly, 2 into 2 pi R0 plus 2 into 2 minus 1 into pi t. Similarly, you will get your L4 is equal to L3 plus 2 pi R3. L3 is 6 pi R0 plus 6 pi t plus 2 pi. R3 is equal to R0 plus 3t. So, 6 pi R0, 2 pi R0, 8 pi R0, and this is 6 pi plus 6 pi, 6 into 6, so 12 pi t. And this can be written as 4 times into 2 pi R0 plus 4 into 4 minus 1 pi t. So, now you get the pattern, and now you can write your ln 2 pi into n into r0 plus n into n minus 1 into pi t, and also you have your Rn is equal to R0 plus Nt. So, these are the two equations that represents the length and the radius. Let us now answer the question. So, what will be the length of the paper when the radius of the roll is 2 inch. So, either you know the length, you find the radius, or you know the radius and you can find the length. So, you have your Rn, which is R0. So, the initial radius of the core is given to be 0.5 and the length is given to be 0.002 times t. If you quickly recall, this is the length, the thickness of the paper, and this is the radius of the cardboard core. So, we got this equation for Rn. Next, it is given that Rn is equal to 2 inch. So, if you substitute here and you can calculate, sorry, this is n, the n, because you have substituted t equal to 0.002. So, if you substitute it here, you will get 2 equal to 0.5 plus 0.002 multiplied by n, and this will give n equal to 2 minus 0.5 divided by 0.002, and this is equal to 750. Now, you substitute this value of n here, this value of t here, and you get the length is equal to 2 pi multiplied by n, which is 750, into R0, which is 0.5, plus 750 into 750 minus 1 into pi into the thickness, which is 0.002. And if you simplify this, this will be approximately equal to 5888.10 inch. So, we took paper towel problem where we have the radius of the wrap of the paper and the length in terms of the variables. If you want to find the length, a relation between the length and the radius, this is how it is done, and you can answer the question that what is the length if the radius is either 2 inch or 2.5 inch or 1.5 inch. So, with that, with particular paper towel problem we have discussed, let us now move to the burning calorie problem. We all exercise to burn the extra few calories that we take so that we can keep ourselves fit, we look good, we look trim and slim. So, the burning calorie model exactly deals like this. So, suppose your weight is 169 pounds and you consume X pounds worth of calories each week. Assume that your body burns off the equivalent of 3% of its weight. This is the weight of the body each week through normal metabolism. and this 3% varies from person to person, becomes slow with the age. In addition, you burn off 1/4 pound through daily exercise. Now, with this information, you try to form a model and then answer the question that what is that x you must take, the calories each week, such that your weight lie between 144 pounds to 146 pounds. So, if you want to formulate this model, let us define Wn, that is the weight after n weeks. The calories you consume is x and W0 is your initial weight. So, you have Wn, which is Wn minus 1 the previous week, and then your body burns 3% of its weight through normal metabolism. So, minus 3 by 100 of Wn minus 1. Then it burns off 1/4 of pound, that is 0.25 through daily exercise, and you add calorie worth x each week. So, this gives a model for your weight, and you want to find that what the range of this x such that your x, so your weight lies between 144 and 146 pounds. So, your weight. So, let us simplify this model. So, you have Wn equal to Wn minus 1 minus 0.03 Wn minus 1 minus 0.25 plus x. This gives you 0.97 Wn minus 1 plus x minus 0.25. So, your W1 is 0.97 W0 plus x minus 0.25. W2 is 0.97 W1 plus x minus 0.25, and you substitute W1 equal to this. So, you get 0.97 W0 plus x minus 0.25 plus x minus 0.25. So, if you simplify this, it is 0.97 square W0 plus x minus 0.25, it is 1 plus 0.97. Similarly, if you do W3, you will get 0.97 cube W0 plus x minus 0.25, 1 plus 0.97 plus 0.97 square. So, this is 1 and here it is 2, here it is 2. So, you can straight away write this will be 3, matches with this 3, and this is 1 less. So, it is 2. Similarly, W4, this will be 4, this will be cube, and ultimately we can get Wn 0.97 to the power n W0 plus x minus 0.25, 1 plus 0.97 plus 0.97 square plus 0.97 to the power n minus 1. So, we can use the GP series. This is 0.97 to the power n W0 plus x minus 0.25, and since this is less than 1, so 1 minus 0.97 to the power n by 1 minus 0.97. So, you write it here again, Wn is equal to 0.97 to the power n W0 plus x minus 0.25, 1 minus 0.97 whole to the power n divided by 1 minus 0.97, and this gives us 0.03. So, you get 0.97 to the power n W0 plus x minus 0.25 divided by 0.03, 1 minus 0.97 whole to the power n. So, the question was that how much calorie you must take so that you can keep the weight between 144 and 146 pounds in 1 year, which is 52 weeks. So, here n is equal to 52. So, I have to find the value of x such that the weight in 52 weeks must lie between 144 and 146 pounds. And the initial value of the weight W0 was 169 pounds. So, all you have to do is substitute this thing, which is 0.97 to the power 52 into 169 plus x minus 0.25 by 0.03 into 1 minus 0.97 to the power 52, and this must be less than 146. And if you simplify this, which is not very difficult, you will get that your x lies between 4.375 to 4.45. So, if you intake your calorie between this, you will be able to bring down your weight to 144, between 144 and 146 from 169. So, with this we have an idea that how burning of calories can be calculated or can be achieved by this simple mathematical model. In my next lecture, we will be talking about kidney function model. Till then, bye bye.